everyone. Today we're looking at a lesson on pH scale. By the end of this lesson, you should be able to summarize the characteristics and interactions of acids and bases. So, please make sure to review acids and bases as well as concentration before you get started. So let's look at pH, what this is. So this is a way to describe how acidic or how basic a solution is. And you do that by determining the concentration of the hydronium or the hydroxide ions present in solution. Chemists use a scale from 0 to 14, known as our pH scale, to describe the concentration of hydronium ions or H plus ions here. And that's why it's called pH, the potency of H plus. So here, if you look at this, we've got, is this water below acidic, basic, or neutral? And then what would the pH range be? So you can see here, there's 9 OHs, there's only 5 H pluses. Since there are more OHs, it would be basic. And since it's basic, it would be on the upper part of that pH scale, which we're going to go into right here. So this is a solution, or the pH of a solution is the potency of the hydroniums present in solution, how much there is. If you have a pH of 7, that is a neutral solution because that means you have like 7 H pluses, 7 OH minuses, or equal amounts, equal concentration. If you have a pH lower than 7, that indicates an acidic solution because that means you have more hydronium ions present in solution. And then the lower that pH value, the higher that concentration is. They are inversely related. So the lower pH, the more acidic your solution will be. pH higher than 7 indicates a basic solution because you have less H plus or H3O plus dissolved. Again, inversely related. So here's what your pH scale looks like, and here kind of shows you your range. Make sure you remember, too, that a low concentration here would be a very large negative exponent. Okay, so negative 14 is a smaller number than negative 2 in terms of an exponent, right? So make sure you remember kind of how that works. So when determining pH, you can use a pH meter, but those are kind of expensive. So normally we rely on pH paper or litmus paper. pH paper will change color when exposed to an acid or a base, and depending on what the pH of that solution is, will show you which color. So you've got a range of colors. So blues, let's say a really dark blue would be a pH of 13 or 14. A lighter blue would be a pH of like 10 to 11. Okay. And then a really red pink color would be a low pH. And the closer you get to like orange, the higher or the less acidic that solution will be. And then usually green is neutral. The pH color chart will tell you the exact pH that you're looking for. So it will break it down even more specific. We also have litmus paper, and litmus paper will determine if it's an acid or a base, but it will not tell you what the pH is because it only turns one color for an acid, one color for a base, does not signify concentration or strength there. Blue litmus paper will turn red in an acid, and then red litmus paper will stay red. And then red litmus paper will turn blue in a base, and then the blue will just stay blue. Okay. Usually I make you test one of each so you can see if they both turn blue or they both turn red. That's how you can tell if it's an acid or a base. If they just turn the color that they were, they just look like a wet piece of paper. So the blue one turns blue and the red one turns red. That means you have a neutral solution. So this shows you if that's a piece of blue litmus paper, you see that it's turning red at the bottom. That means it was dipped into an acid. We can look at certain properties based on the pH of a solution, and strong acids, for instance, will completely ionize when dissolved in water. So that means you're going to completely break apart. HCl is a strong acid, which means for every molecule of HCl you put in, it will break up into H plus and Cl minus. Every time, you're not going to have any left over. Strong bases will completely dissociate in water. So NaOH, for every formula unit of NaOH, you get an Na plus and an OH minus. None of them stay together. But if you have weak acids and bases, they only partially break up. So you'll have some that break up into their pluses and minuses, but you'll have some that stay together. They don't want to break up all the way. And that just means that their polarity is not as different. Strong acids and bases are strong electrolytes, whereas weak acids and bases are weak electrolytes. So that does show their conductivity differs as well. So this is a strong acid. All right, guys, so hopefully now at the end of this lesson, you should be able to identify acids and bases based